Hey there, quick question. Have you ever wondered how Netflix knows exactly what to recommend you next? Or how your bank flags a suspicious transaction before you even notice? Or how Google Maps estimates your arrival time so accurately? It all comes down to three fundamental skills in machine learning: classification, regression, and clustering. These aren't just buzzwords. They're the core techniques behind how AI systems understand, predict, and group information. If you ever plan to build AI solutions, or even just understand how they work, these three concepts are absolutely foundational. Why? Because no matter what AI tool you're using, whether it's detecting fraud, forecasting sales, or segmenting customers, it's probably using one or more of these three methods under the hood. So today, we'll break them down, simply, clearly, and with examples you actually care about. All right, let's dive into classification. This is one of the fundamental ways AI learns to make decisions. So what is classification? At its core, classification is about sorting things into categories or labels based on their characteristics. Imagine you have a basket full of fruits: apples, bananas, oranges. You want to teach a computer to look at each fruit and say, this one is an apple, or this one is a banana. That's classification, assigning the right label to each item. In AI, classification means the model looks at input data and predicts which predefined category it belongs to. These categories can be simple, like spam or not spam for emails, or more complex, like identifying types of animals in pictures: cat, dog, bird, or fish. So classification answers the question, which group does this belong to? Now, how does the AI do this? First, it learns from examples. This is called training. If we're building a spam classifier, we feed the AI thousands of emails already marked as spam or not spam. The AI looks for patterns, like suspicious words or sender details. Then when it sees a new email, it uses what it learned to guess whether it's spam. Classification can be binary, where there are only two labels, like spam versus not spam, or multi-class, where there are more than two labels, for example, sorting photos into beach, mountain, or city. Multi-label, where an item can belong to multiple categories at once, like a news article tagged both technology and health. In short, classification is a powerful way to organize and understand data by labeling it. There are several algorithms that help AI learn how to classify data accurately. For example, decision trees work like a flowchart, asking yes/no questions to narrow down the category. Random forests combine many decision trees to improve accuracy. Support vector machines, or SVM, try to find the best boundary that separates different classes. And neural networks inspired by the brain learn complex patterns from data to classify images, speech, and more. Each has its strengths depending on the data and problem. Now let's connect this to some real-world examples to see how it works in different sectors. In retail, AI classifies product reviews as positive, negative, or neutral, helping businesses understand customer feelings quickly. In finance, it classifies transactions as legitimate or fraudulent, helping to detect scams early. Healthcare uses classification to analyze medical images and spot diseases. In education, AI can classify student answers as correct or incorrect to provide instant feedback. These examples show how classification helps AI make sense of complex information by putting things into clear categories. So remember, classification is all about teaching machines to recognize and assign labels, a foundational skill that powers many AI applications you encounter daily. Now let's talk about regression. While classification sorts data into categories, regression is about predicting a continuous value, a number that can take on many different values, not just a label. Think of it like this. Imagine you want to predict the price of a house based on features like its size, number of bedrooms, and location. Regression helps AI look at these details and estimate a specific value, say $350,000. So regression answers the question, how much, or what number. How does it work? Just like with classification, AI learns from examples. It sees many houses with their features and actual prices. It finds patterns. For example, bigger houses usually cost more, or houses in a popular neighborhood sell at a premium. When given a new house's details, the AI uses these learned patterns to predict its price. Regression can predict many types of numbers: housing prices, stock market values, temperature forecasts, sales figures. And it's not just about single values. Sometimes regression models predict changes over time, like how a company's revenue might grow month by month. In AI, regression models use mathematical functions to fit the best possible curve or line through the data points, so the predictions are as close as possible to real values. Regression also uses different techniques to predict numerical values. The simplest is linear regression, which fits a straight line to data points, showing how one variable changes with another. Polynomial regression allows for curves instead of just straight lines to better fit more complex data. Ridge and lasso regression adds some constraints to avoid overfitting when dealing with many variables. More advanced methods include support vector regression and neural networks that can model complex relationships. Now let's look at some examples across different sectors. In retail, regression helps predict how many units of a product will sell next month so companies can manage inventory efficiently. In finance, regression models forecast stock prices or interest rates, guiding investment decisions. Healthcare uses regression to predict patient risk scores, for instance, the likelihood of developing diabetes based on health indicators. In education, regression analyzes students' test scores to predict future performance and identify who might need extra help. So, regression lets AI not just categorize, but estimate real-world values, helping businesses and people plan better. To sum up, if classification answers what type, regression answers how much. Now, let's dive into clustering. Unlike classification and regression, clustering works with unlabeled data. Imagine you have a big bunch of data points, but you don't know their categories or values up front. Clustering helps AI find natural groups or patterns without any predefined labels. Think of clustering like sorting a pile of mixed-colored marbles into groups based on their colors, but you don't know beforehand how many colors there are. The goal is to group things similar together so that items in the same group are more alike than those in other groups. The AI looks at the features or characteristics of each data point, like size, shape, or behavior, and measures similarity between points. Based on this, it groups the data into clusters where members share common traits. Clustering is an unsupervised learning technique because it doesn't rely on labeled examples during training. There are many clustering techniques, such as k-means, which partitions data into a specified number of clusters, and hierarchical clustering, which builds nested clusters in a tree-like structure. Other popular methods include db-scan, which identifies clusters based on density, making it good for finding irregular shapes. Now let's look at some real-world examples. In retail, clustering is used to segment customers based on shopping behavior. One cluster might be bargain hunters, buying mostly discounted items, while another prefers premium products. This helps businesses personalize marketing strategies for each group. In finance, clustering detects unusual transaction patterns that might indicate fraud. Transactions that don't fit into any existing cluster of normal behavior can be flagged for review. In healthcare, clustering analyzes patient data to identify subgroups with similar symptoms or risk factors, helping to create targeted treatment plans. So, to recap, clustering helps AI discover hidden groups in data without needing prior labels. It's like being handed a jigsaw puzzle without a picture on the box. Clustering helps find which pieces naturally belong together. This technique is especially useful when you want to explore data, detect patterns, or identify anomalies. So, to wrap up what we've learned here, classification, regression, and clustering are the foundational building blocks of how machines learn from data.
Classification helps us put things into neat categories, like deciding if an email is spam or not. Regression allows us to predict numbers and values, such as estimating house prices. And clustering uncovers hidden groupings within data without any labels, helping us find patterns we didn't even know were there. Each technique has its own strengths and use cases, and together they form the core toolkit for many AI applications you see in the world today. Understanding these concepts is essential not just for technical experts, but also for anyone who wants to grasp how AI systems analyze and make sense of the data around us. As you continue your AI journey, you'll encounter these ideas again and again in more complex and fascinating ways. And remember, behind every smart AI application, there's a simple concept like classification, regression, or clustering quietly doing the heavy lifting. Let's keep building on this foundation in the next chapters.